because no? Yes? Okay, I'll try my best. So I'm Nicolas Dufresne. I work for Collabora. I've been hacking on GStreamer for over 10 years now. I also hack a bit on libcamera. I've earned a t-shirt this week. And I'm going to give you an update of what is happening in GStreamer since last FOSDEM, basically. So, in numbers, at last FOSDEM we were releasing 1.22.0 of GStreamer framework. And since then we did 9 bug fix releases. We had, so the Rust component, oh, that's off, anyway. So the Rust component, I know why. Let me fix that quickly, sorry about that. Ooh, that's using time. Sorry about that. There we go. And just a different version of the tool. So as we mentioned last year, the Rust bindings and Rust plugins actually lives in separate repository with their own release cycle. So there was 13 releases of the Rust bindings, 18 releases of the Rust plugins. There has been 13 security fixes that are basically security issue reported by researchers, all in C code, and over 600 backport on the C side and 600 backports on the Rust side. As for the development, we haven't released 1.24 yet, even though Tim actually mentioned that it might have been released, it should have been released. We'll work on it. I think we're super close, but understand that we had 1,400 merge requests on the C side, 400 merge requests on the Rust side, about 5,000 commits plus 750 commits. That has been quite a lot of work, and it also introduced a bit of instability in the development tree that we need to take care of. On the community side, one of the big changes that we're slowly, so we didn't kill it, we're slowly moving from IRC to Matrix, so you can join us to the Matrix community, which brings basically different topic channels, so you can actually have a channels that are dedicated to a topic, which makes the channels a bit less noisy. We also introduced this year for support a discourse, which is a forum. It's something that has been requested for a long time. People always wanted to use our issue tracker as a forum, and we didn't want to. Now we give the users a forum to do that, and it actually killed the mailing list. Literally, I don't really get anything there anymore. Now the rest is going to be quite fast. Might skip some of your contribution if you're a GStreamer contributor because there's too much. But I'm going to give you an overview of what changed. This is things that didn't fit. So at the very core, in the GST meta, we've introduced the ability to serialize and deserialize the meta for IPC purposes. We introduced the GST analytics relation meta, which is an attempt to standardize the analytics data exchanges between different ML systems, AI systems, or standard OpenCV kind of analysis. Small, but there, insert bin is now in your registry, so it's an element that you can discover and that you can start learning about 4 years later. ONNX have gained inference elements, 0 copies being refactored. This is the most active machine learning set of elements in GStreamer. ORC has gained AVX2 support, which increased a lot the software processing on recent laptop. You don't need to mux with encodebin, which makes encodebin a lot more useful in a lot more situation. WP source has been updated to the latest API. And finally, I think this feature is kind of cool, and it didn't fit anywhere. QML6 has a mixer, so it's a mixer to display, which is a lot more efficient than doing tons of render paths to get a single buffer to then render it. On the codec and parser side, we've did quite an important change to the H.264 parser to make our frame splitting actually spec compliant. It's not yet fully stable. We still have some regression to look around, but at least it means that you can do fun stuff with your bitstream now, and GStreamer won't think it's multiple streams, multiple frames. Small addition, codec to JSON. It's just a set of plugins that takes your bitstreams, dumps the headers, stream headers, and slice headers, and frame headers, and makes a JSON out of it so you can actually read it. It's very useful if you develop an encoder. JPEG parse. There was no JPEG parser in GStreamer officially. Now there is one. You no longer have to implement a parser in every single JPEG decoder. MPEG-123 became our primary MP3 decoder, replacing MAD. Vulkan Video, actually, we're early adopter of the Vulkan video standard, and we now have an H.264 decoder that has been merged, and there's more work coming. There's a then we added a couple of codecs, LC3, audio codecs from Google's PeedHQ, which I'm less familiar with. We've enabled support for the SVT AV1 and software encoder. And on NVIDIA codec side, HDR, stream sharing. On AMD proprietary codec side, we got HDR, HEVC, and AV1. Streaming side. So I put a little Rust logo next to what is actually being written in Rust, and I'll explain a bit further why later. So you can see that the WebRTC sync now can input pre-encoded stream support. It has D3, D11, and QSV encoder support. There's a base, I think it's a base class for the WebRTC syncs, and out of that there's Genus VR WebRTC sync, VR for video room, not for virtual reality, and AWS sync also. That makes your life easier. It basically handles the signaling for you, and it also handles the encoding for you. It handles the bitrate adaptation for you. So it's much easier than going straight to WebRTC bin. We also have some enhancement on the WebRTC source, including turn support. We now have a WIP server source to go with the WIP client source. We have an HTML API. I must admit, I didn't go through deep on what that thing do, but it's on top of it, and it offers an HTML API. It's a kind of separate project inside the project. And another mention, there's basically a new feature. You can do synchronized playback in jitter buffer using your system clock if your system clock is synchronized with your media clock. That's more of an embedded use case, but yeah. More about streaming. NDI source has gained 0 copy. There's a new element called AWS put object, which is not very good for throughput, but it's a much lower latency for a small chunk of data that you want to upload to AWS Cloud. HLS CMAF sync finally, so you can serve CMAF, which is the common fragmented storage for all the fragmented implementation, whether it's Dash or HLS. You can now stream, you can now serve HLS using CMAF in GStreamer. The fragmented Muxer has gained AVP8 and AV1 support. And another one, which is a bit niche, we now expose a W3C media source extension API that mimics the web API that you can bind into whatever you want. The intention with that is basically to be able to share your JavaScript between something that runs in your browser and something that runs in kind of standalone player. Specifically on the binding itself, I probably missed a couple of things there, but there's GES, so GStreamer Editing Services bindings. There's bindings for the VBI parser and encoder. The handling, there's accessors for the pad probe, which makes using pad probe a lot less verbose. And there's bindings for some metadata like the video SE user data unregistered, the RTP source meta, and yeah, a lot more. This binding is extremely active and maintained. An interesting one, it's a bit uncommon to have such an amount of activity on video formats, especially pixel formats. And yeah, we've seen 20 new pixel format on the software transformation side, 27 new pixel format in GL, 25 in D3D11. And I'm actually skipping D3D12 and CUDA here, which probably have the same numbers. We introduce quite something. It's basically the ability to pass through DRM, Linux DRM pixel format and their modifier that enables GPU compression on Linux mostly. And that should make your video playback on your laptops a lot faster. It comes with helpers to do caps negotiation, and all the design for the negotiation also is published on the website. It's implemented in VA, MSDK, Wayland, and there's more support coming. Small, but because it came from a new contributor, someone added 10-bit support to the WebM Alpha support. We also introduced 10, 12, 14, 16-bit software debugging, which, I mean, I think nobody had touched the debugger for 10 years, so it was a bit of a surprise, but then we're back to the modern days. I think it's mostly because of libcamera. And yeah, but a lot of activity this year has been on the Windows side, mostly done by a single person. So let's get the Windows updates. So on D3D11 support, there's an IPC source sync that has been created, so you can share basically D3D textures across processes. You now have an overlay element, a bit like the Cairo element. You get a draw callback, and you get to use the system context to draw. That's about it. That was a question from last year FOSDEM. We now have D3D11 support for Qt6. Lots of improvement and pattern and stuff in the D3D11 test. You can now pre-compile your HLSL shaders and cache it on disk. There's basically the NVIDIA decoder can now output to D3D textures. And you have D-Write support to optimize the rendering of overlay, which is basically a companion to D3D11. On D3D12, that's a much newer subsystem, but it's equivalent, and it's getting almost all the same features now as the D3D11. So added MPEG-2, H.264, HEVC, VP9 decoder. I'm actually surprised not to have AV1 there. It's probably there. I probably just missed it. And H.264 and HEVC stateless encoders, so they're much harder encoder to implement because you have to do more work. And compositor overlay, screen capture, color space converter, same pre-compilation support and shader support. It didn't do zero copy until this year, so zero copy threaded decoders to improve the throughput, and it's interoperable with the D3D11 framework. So that's most of the Windows update. On OpenGL side, well, most of the work has been to be able to negotiate the DRM modifier so we can get compressed video frame into GL, zero copy into GL, and render it. Just recently, we also added the ability to pass through the DMF formats so that we can upload to GTK4 the rendering to your compositor. So that's coming. You'll be able to basically skip your GPU completely so it can shut down while you watch your video. We added surfaceless display support, and the GTK4 paintable sync in Rust now has GL window support. More specifically to Unix-like systems, VA, Wayland, and MSDK, I mentioned that already, have the DRM modifier support. We have a VA NV1 encoder now implementation for the newest brand of Intel laptop, mostly. The Android media codec now has been ported from being fully C calling into Java to be implemented using the NDK, so it's implemented in C, except for, I think, one callback. It reduced a lot the overhead for codecs on Android. And we added AV1 support. There's a new set of elements for Unix, which is the Unix FD source and FD sync. It kind of replaces shrim source and shrim sync. The main difference is that it actually passes through the caps, and it serializes the GStreamer meta to the other side, and it also passes memfd or dmabuf or any file descriptor that you would be streaming. So 0 copy, unlike the shrim source and shrim sync element. OSS, that's Open Sound System that is still used on BSD these days. Now you can enumerate your audio device, which was quite a missing feature. The Wayland Sync have gained support for DRM DOM allocator on Linux. It's not exactly automatic yet, that's coming. But what it does is that when you do software decoding, you can decode into a GPU importable buffer, and that means that your Wayland compositor is going to be able to use a hardware layer, which removes some copies, and you're already software decoding, so whatever gain you get, that's a gain. And that makes software decoding better. Now, embedded Linux. We added a v4l2 AV1 stateless decoder. For me, it's 2 years of work because we also did the kernel side of it. People from Pengutronics added the UVC sync element, which is a companion to the Linux UVC gadget framework, which basically lets you use GStreamer to create a webcam out of your little chip that supports the appropriate USB protocols. In v4l2, stateless codecs are now CI tested using QEMU and a virtual driver called Visual. So it does not really decode, but it produces image that is modified based on the parameter. So it's basically good for catching changes, which are usually just a regression, and it actually works. So we're pretty happy. It runs in 10 seconds. That's our fastest decoder out there. v4l2 source now cares about frame rates, so when you use v4l2 source, you may get something better than 2 to 5 frames per second by default. It's pretty nice. The GC allocator gained a dmabuf DRM DOM allocator. Hopefully we're going to get a GBM also allocators in the future. And we also have buyer support integrated into v4l2 source. And yeah, we've improved we've improved a bit the v4l2 stateful decoders in order to try and get the Raspberry Pi 3 and 4 experience a bit better. And that included the new dynamic resolution change method in the specification and HDR10. There was quite a lot of work on closed captioning. I kept just a few lines, but basically there's a muxer for 608, CA 608. The CC combiner has been greatly improved. There's a CA 608 renderer overlay. And it looks like the development of that is moving toward Rust now, and there's a converter now for the older closed captions to the newer closed caption standard in the Rust plugin repository. We've retired some stuff actually this year, so the GST OMX is now gone. It was completely unused by Raspberry Pi. We never implemented any Android support because it was not exactly a real OMX, and basically there has been no contribution for years. So we decided to remove it. Kate, which is based on libtiger. There's basically, it's becoming difficult to get libtiger. So we were like, yeah, let's stop supporting that. And finally, we removed the use of gslice all over the code base, simply because gslice has been outperformed by the system heaps now. So we'll use the fastest one, which is the simplest one also. So malloc is faster than gslice. We have futures plans. I had no intention to actually spoil anything, but I'd like to underline that lately, there's an effort that I've started to actually rewrite the RTP stack of GStreamer, mostly for security reason, because it deals with a lot of network input, but it's an opportunity also to fix some of the intrinsic performance issue of the current implementation. So we really hope that that's going to be better. It's definitely a multi-year work ahead of us before that replaces the existing stack. I also personally strongly consider contributing a replacement for our parsers, our bitstream parsers, as being responsible for 50% of the security issue this year. So that's definitely just the AV1 parser. I think it's the 4th in a row. So we have 4 bug fix releases that are made quickly because of the AV1 parser. And the first one actually came with a nice code execution example from the researcher. So it's very, very concerning. If you want to learn more about these things, I've been really on the surface, but all our GStreamer conference across all the years are recorded by UBTV, UBcast, and you can go watch them and you get more detail. We had one in October, which all fresh and covers a lot of this. And please, if you want to get more in touch, there's going to be a GStreamer conference again this year in October, and it's most likely going to be in Montreal, actually, first time out of Europe. Thank you, and we have 3 minutes for questions, I think. 5? Oh, okay. Sure.
Can you say a bit more about the W3C media source extension, why you chose that, and if you're seeing any active use cases with it?
So the question is, can I give more context, right, around the W3C media extension? So our use case was, basically my team did that. So our use case was that we had some people that wanted to use Shaka Player, which is a JavaScript player, but without the browser because their device is not strong enough to host a browser. So basically there's not enough RAM, there's not enough CPU, but they really wanted to share the same player. And the idea is that the first step was to make basically an API that is like MSC inside of it. We didn't create it. We ported it from WebKit. And that is really easy with GObject to create then, to expose then a JavaScript API that you can use in Node or something like that. Yes?
How hard is it for someone who knows the C API quite well to get started with writing Rust plugins?
Please repeat the question.
Yeah. So the question is how hard it is for someone that knows well the GStreamer C API to write it in Rust. Do you have a better answer than me on that? I don't know. I don't. I mean, I've personally been 4 last year in kernel development, so I haven't really been into the Rust thing. But from my experience, my tutorial trials, if you really know GStreamer, because we have such great bindings, and you have so many examples now, it's not that hard. The hard part is basically the discussion that you have with the compiler that is telling you that, that you don't really understand what you're doing initially, that you don't really understand what's ownership, and but it's part of Rust. You really get intimate with the compiler.
So could you say if you want to develop a new plugin that you should go to Rust, or should you still stick with C for the time being?
I think it's the best recommendation to give. So if you were to develop a new plugin, should you go to Rust? I think my answer is yes.
Yes. So it's great to know plugins in Rust. Are there any plans of doing any work on the core in writing in Rust?
You'll have to repeat the question for myself.
Any plans of rewriting some of the core GStreamer in Rust?
So the question is if there's any plans to rewrite some of the core in Rust. For now, no. I mean, we don't consider the RTP stack as a core because it's actually a plugin. So yeah, there's nobody actually shouted out that they were doing that. There's few things that could actually be in Rust, like someone Sebastian actually made the PTP helpers in Rust that was kind of autonomous and independent. That fits. But yeah, in the short term, no. I think we're good. Well, thank you very much.